lecture, like, they talked about how like gravity just doesn't actually exist. It was really weird.
It's kind of like the light suckers. The light suckers. Or dark suckers. Dark suckers.
Light.
Do you see that right there? That's a dark sucker. So our world is filled with darkness. However, when I turn this switch right here, the darkness is absorbed through that thing up there, and I can see. But when I turn it off, it doesn't absorb the darkness, and it releases that darkness down into our area, and that's why it's harder to see, because there's more dark. See, it's already filled with dark.
Question.
Yeah.
Why does the absorbing dark make it a little brighter?
Why does absorbing dark make it brighter?
Yeah.
Why doesn't it?
It's the dark sucker, not the room.
Yeah.
The room, but why does that glow?
Why does this glow? When it absorbs the dark?
Yes.
Because it's pulling in that energy. So it's the energy. Both. It's the same. That's my pseudoscience example. It makes a lot of sense.
Gravity not existing totally makes sense. It's like eventually the age of Ultron, where the city's just going upward. That's the Earth. It just goes upward.
All right.
Mr. Bowers.
Yeah.
Dude, Mr. Bowers.
Yes.
What if the oceans aren't rising and just Earth is just shrinking?
That is one option.
Like the gravity is so strong that it's compressing the Earth into the
All right.
No, water isn't compressible.
So, if you guys look at this example, can we move on?
Yes. Let's move on.
Yes, please.
Yes,
All right. So a student pulls a wooden box along a rough horizontal floor at a constant speed. This is just applying what we kind of learned yesterday. All right. By a constant speed, by means of force P, as shown to the right, which of the following has to be true? All right. So if we look here, all right, it's kind of on the right on the edge, which is unfortunate, but it's staying flat. Okay. So is P going to be greater than F if you're pulling it forward? Oh, yeah, absolutely. You're going forward. So that's true. All right, so that's true, which means it can't be that, or that. Okay, is N equal to W?
No.
No. All right, and it's going to be less than W because it's sitting flat on the ground. All right.
Because the arrow is bigger.
Arrow's bigger. Okay, that was pretty easy. All right. Da-da-da. All right. Now we're not really gonna do this because we've been talking about these type of problems. All right. I really want to get to the inclined plane. All right. So similar problems. You're just looking at the force graph. All right. That's what you're calculating. All right. For each of the stages, will a scale read greater, less, or equal to the person's weight?
Oh, I thought he was like an old person.
Yeah.
But it's an elevator.
Constant speed, would that be greater, less, or equal to a person's weight? Equal. Okay. What if you're going up in an elevator?
Greater.
Would be greater. Okay. Down. What about downward? Like you're just falling at gravity. It would be zero. Would be zero. Yeah.
Which is less.
In a vacuum. Don't think air resistance or drag. All right, zero. All right, now we're going to get to my inclined plane. Once again, gravity. We're talking about gravity in these two problems, all right? The beauty of inclined planes. What a beautiful sight. Okay, now this is what we're going to be doing today, all right? We got my nice inclined planes. We'll probably finish this lab on Monday, All right, so a block can accelerate along the surface of the place. All right, the x and y are rotated to the surface of the plane. So here's my x, here's my y. Okay, gravity is straight down. Okay, and then the force normal is going up. All right, so that's what our inclined plane looks like. Okay. All right, so here's another example. Now, what this is basically telling us is whatever the angle is here, that's going to be our angle related to gravity. All right? So those two are going to be the same. Those two are equal. And how I like to solve inclined plane problems is I like to either tilt your head a little bit or draw it differently. All right, so I'm going to draw this flat. Okay, so if I draw it flat, you got your box. Okay, you got your force normal going straight up from the box. Okay, and your force of gravity is actually going to be like right here, right? So it's actually going to be force of gravity, right? Just tilting it to the side. And whatever our angle of the slope is going to be our angle right there. Does that make sense? That's what this is showing us right here. So whatever this angle is going to be whatever this angle is here. Does that kind of make sense? All right, that's kind of the biggest thing. That's why I kind of like to draw it flat so that it's easier to see.
What is the force going down? Is that just?
There technically isn't. There isn't. Not in this one. Because we have our force normal and force gravity right now, unless we apply a force. Okay? All right, so let's try one example out, and then we'll get into our lab. We're going to try one example. All right. After searching for Billy and Carl, Jonathan spots Billy sliding Carl a 3 kilogram. I think he's losing more weight. He used to be 10, then he's 5, now he's 3. He's losing weight. All right. So a 3 kilogram box down a smooth, frictionless inclined plane of 30 degrees. Okay. So if I look, I know that this angle is going to be 30 degrees, right? So my gravity is at a 30-degree angle. Okay. Let's see, what else do we know? 3 kilogram box. Okay. 3 kilogram box, right? Now we know that. Draw the FBD, find the normal force of the block, find the acceleration of the block. All right, so the FBD is the drawing, right? All right, so find the normal force. What is the force going up? Okay. What is the force going up? Try it out. Oh. Don't look.
I got it.
All right.
Yes.
Say what? There we go. Anybody got a guess for the normal force? Yeah.
25.46 meters.
All right. So that was kind of on the board. So how you're correct. All right. Now, how you do this? All right. How you do this is you got to find the force. You got to find this value right here.
There wasn't a value.
There is not. We got to find the x and y to find the hypotenuse,
Oh, okay.
if that made sense. Okay? Got to find the x and the y. All right? Got my notes over here. All right. So let's see. The force of gravity. All right. Force of gravity is equal to mass times acceleration. The mass is 3. Acceleration is 9.8, negative 9.8, right? All right. So what's the force of gravity? 29.4. Okay. Now, that will help us solve for our y component here. So what's the y component? All right. So we know the hypotenuse, and we're trying to find the adjacent. So we're going to use ka. So ka so.
When we solve for gravity or force,
Yes.
gravity, that's the hypotenuse.
Yes.
We solve for-
Absolutely. Great question. So cosine of adjacent over the hypotenuse. And that gives you your answer, right? Because that'll give you this value, which is going to be the same as your normal force. Yes.
Are we ever going to use derivatives in this class?
I don't even remember what that is.
Derivatives are easy.
Derivatives you'll find in AP Physics C,
Cool, I'm not taking that, so we're good. Never mind. Continue.
mainly.
Happiness, eat.
And I'm not teaching that class.
Awesome.
Way like, yeah.
Derivatives suck. Or will the force ever be negative, like the force of gravity? Do you write it as a negative, or is it just always positive?
I mean, in this case, yes, it's going to be negative, but like going down. So technically, our value here is a negative y, right? So what was our answer? 25.46, so 25? 25.5. So technically, that's a negative 25.5 going down. We're trying to find our normal force, which is in the positive direction, so it'd be a positive number.
Wouldn't this increase this be 30?
Why would you bring it up?
Yeah. Okay. Okay. Does that make sense? So now we have to find the acceleration. Okay? Find the acceleration. So force is equal to mass times acceleration. So we're going to find the acceleration in the x direction. All right? Find the acceleration in the x direction. Okay. What would that value be? You can do a squared plus b squared equals c squared. What do you guys get? Yeah?
4.9 meters.
4.9. You can round. Or 4.9.
I got 14.6.
Yeah, I got 14.
Do I need my calculator?
That one wrong. What the acceleration?
I did it, so I thought you were mine, but it's 9.8.
It is.
I got it out of Kansas house. 14.6 newtons.
Yeah.
Then convert it to
Okay.
acceleration.
So let's see. So 25.5 squared plus 29.4 or 20, minus 25.5 squared. Take the square root of that. So I got 14. All right. So 14.6. We'll do 14.6 is my force. Okay. So that's my force. Mass times acceleration. Okay. So I have 14.6 in the x direction. My mass is 3, and I'm solving for acceleration. Okay. So 14.6 divided by 3. I got 4.87, 1 sig fix. So the acceleration is 5 meters per second squared. Okay. So when you're solving for inclined planes, the biggest takeaways I want you to see, biggest takeaways, the normal force is just the force in the y direction. All right. The acceleration, you'll have to solve what it is in the x direction. That's why I like drawing it on a flat surface like this and having gravity here, because our acceleration, we can just look at it going straight, right? We can see it going just straight across. Yes.
Are we going to do acceleration of objects on curved surfaces?
Oh, no, not this chapter. No. Okay.
Wait, hold on.
Yes.
So I see how you got the number 14.6, but I don't see how that logically would make it acceleration.
That's the force.
Or, yeah, force, that's what I meant.
Okay.
I got everything after that. Oh, because it's the same direction as the, like the slope is.
Correct.
Okay, I just didn't see that for a second.
Yeah. Oh, you're good. That's a great question. All right. So today, you guys are going to start a lab experiment. All right. Like I said, we're going to definitely finish this on Monday. All right. What you guys are going to do is you're going to use an inclined plane. All right. And you're going to analyze first. Like I said, we're using Hot Wheels, which isn't the best because they kind of go everywhere. But we're going to do good. We're going.
It's okay. This class is known for being very calm and collected, so that will not be an issue.
That's what I'm talking about. So you guys are going to be,
That's probably your favorite, right?
obviously, you're my favorite physics class. What? What?
So that also means we are your least favorite.
Yeah.
All right. So you guys, I almost hit the cows and I got really worried.
That would have been funny.
All right, you guys are going to be calculating the mass. You're going to be measuring different angles. All right. You're going to calculate the different forces. All right. Let's see. Force of gravity, force in the normal. Find the acceleration. All right. We're doing everything we just covered. All right. That's example 1. Example 2 is you're going to counter it with a mass. All right. We're going to have a mass to equal this out. And what I used, which works pretty good, like I said, if we had the carts, we would use an actual mass. However, I don't have the carts, so we're going to use a penny because Hot Wheels can't pull that much. Okay. So you're going to determine what angle actually match or counteracts the car and the weight. Okay. So for example, if I pull this up,
Wait, hold on. What are you doing? Oh.
if I pull this up, the car's force is greater, right? Okay, so you're going to have to calculate at what angle do the two equilibrate. Okay? So like what angle does the force of the car match the force of the penny? So this won't move. Penny's right here.
Oh, hey, there's a thing. I didn't see that far.
There you go. Okay. So you guys can set it up.
I found
I
it.
got what?
I said I found the angle.
Very good. All right, so I got this. I got your ramps. You guys don't need any of this. I got string cars, pulleys, cars. I already said cars, and we should be good to go. All right. You only need one lap sheet per group. Max of 4. Max of 4. All right. You only need one lap sheet. I got cars. I think.
Look at this.
I don't know. That orange one doesn't go straight to.
Does it go
Oh, you want that one?
Nah, it's crashed. It's no good anymore.
It's total. Screw it up.
Where's the port of
Barely. Yes.
Okay, good enough.
Yeah, it's good enough.
I say, okay.
It's pretty heavy. Penny.
You want the
Let's
one
grab you a
without
penny.
wheels? No. Or do you want this one?
Penny for your thoughts. Penny for your thoughts.
That's too cheap.
Penny for your thoughts.
I mean, look at these.
Hey, penny for your thoughts.
It's a phone.
What's your thoughts?
Phone.
I know, but what are you thinking right now?
I want to be here.
Oh, I'm so sorry. Penny for your thoughts?
Sure.
Okay, I'm cheap.
All right, what am I thinking of? I'm thinking of holding a pen.
Oh!
Penny for your thoughts?
Well, I'll take a penny.
No
I
penny.
do have a penny. I'm gonna
Ah.
go my pre-count test today.
Oh, pre-count.
Yes.
Oh, I'm backwards.
You're gonna do great though.
Thank you.
Yeah, I don't know.